So that's when we need the chain rule. I'm going to show you first how to set that up formally, or the sort of the long way round, and some people always use that, but I'll also show you a shorter way as well. So the full formal way of using the chain rule is to write the expression again, but to use a letter instead of the inner function. So we typically use the letter U, and I'm going to say we're cubing that. So there what I'm doing is setting up U as being 4x plus 3. I'm going to write that out as well. That's the substitution that we're using. So what we're doing is we're labelling the inner function, and that allows us to differentiate the inner and the outer like an onion. We'll start by differentiating this over here. We've got y and u, so when we differentiate we'll get dy by du, and that will be 3u squared. We'll also differentiate the inner function, so that will be du by dx, and when we differentiate that we'll just be left with 4. What we're looking for when we differentiate this whole thing is dy by dx, and we can get dy by dx by using these two. So can you see that if you multiplied these together, the du would cancel out and you'd be left with dy by dx. So this is the same as that, but we're sort of unpicking it into its different parts using u. So now we can times these things together to get dy by dx. So dy by du is 3u squared in this case, and du by dx is 4. And then we can put the u back in to get it in terms of x. Great! It's quite a powerful tool to use really, because the only other way of differentiating this would have been to use a binomial expansion to expand all of that out and then differentiate each term, which would take a much longer time than this. So it's a very powerful technique to use. So that's the long-winded formal way of writing it out, and there's nothing wrong with doing that every single time if you want to. But I will just show you another way of thinking about it that's quicker. So this quicker method isn't a different method, it's just a different way of thinking about it. So remember when I wrote out dy by dx is du by dx times by dy by du. So it was kind of the derivative of the outer function times by the derivative of the inner function. So if you don't want to write it all out, you can do that kind of by looking at it and holding it in your head. What we're going to do is differentiate the outer function. So if you sort of put a finger over the inner function, you've got something cubed. So when you differentiate that, you get 3 times that something squared. And then we're going to look at the inner function and times by the derivative of that. So now you ignore the cubed, just look at the inner function, 4x plus 3, and the derivative is 4, and then you can tidy that up. So remember, that is what we got when we wrote it out the long way. And if you practice that a few times, then it gets a lot easier to do. So let's do some more examples now. I'm going to give you 4 examples to work through, and here's 2 of them to start with. You're welcome to use either the long or the short way. If you want to do the longhand, you can set up a substitution that u is 5 minus 3x. Great, well done if you got that one right. This one I'm going to just do the shorthand version. So talking you through that. The inner function is 3x squared plus 4, so I'm just going to hold that in place while I differentiate the outer function first, and that is something to the power of 5, so it will be 5 times that something to the power of 4, and I'm going to multiply by the derivative of the middle, the inner function. So differentiating 3x squared gives me 6x, and the 4 will be dropped. And just simplifying that. Fab, let's look at 2 more examples. please do pause the video and have a go at these. These ones are slightly harder than the previous two because they need rewriting before you can differentiate them. So I'm going to rewrite them with powers instead of that root. And I'm going to do it the quick way as well. So I'm going to differentiate the outer function and then times it by the derivative of the middle function, the inner function. So that'll be 6x squared. And then I'll simplify that, so gathering the half and the 6x squared to give me 3x squared. And you can, if you want to, you can put that back down on the bottom as a root, but you don't have to. Great, well done if you got that one right. Let's have a go at this one now. I just realised I should be writing dy by dx and I've stopped doing it. Bad habit. Write that there. Okay, let's have a go at this one. I'm going to pull up the bottom with a negative power and then differentiate. And just be careful when you take one off the power, it's -4, not -2. And that's the derivative of the inner function, 4x cubed. Simplifying that. And again, you can put that back down to the bottom if you want. Great, so you do need to practice quite a few of these until it becomes much easier and quicker for you. But you do start to get the hang of it pretty quickly, I think. And they do look pretty impressive, don't they? Before you learn the chain rule, those things look horrific to differentiate, but suddenly you can. It looks quite impressive. I want to look at differentiating sine, cos and tan now and use the chain rule on those. So I don't know if you've seen this language before. This is how to say the derivative of sine is, the derivative of cos is. So it's just d by dx of whatever you're trying to differentiate. This is if you're writing just expressions without y equals in them. So when I differentiate sine x, what I get is cos. So that's a straight swap to cos. When I differentiate cos, I get sine, but it's a negative, so the sign, not that sign changes, positive to negative, or negative to positive. And tan goes to something completely different. It goes to sec squared. Wherever you are, whatever qualification you're taking, you might be given those, or you might have to learn them off by heart. But let's look at using them now with the chain rule, and it's different. How you use the chain rule is different, obviously, whether these are the inner or the outer functions. So we're going to do a couple of examples when they're the inner function and a couple of examples when they're the outer, and you just need to get used to using either way. We'll start with a couple of examples when the trigonometry bit is the outer function. So here we've got sine of something. If you wanted to use the full longhand way of writing, then your substitution would be that inner function 3x plus 4. So it'd be sine of u, and you can go through with that. But I'll show you how to think about it the quick way. So we're going to differentiate the outer function as usual first. When we differentiate sine, we get cos. I don't know why I'm so bad at remembering to write the dy by dx today. So we differentiate the outer function to get cos, and that will just stay there for a second, and then we multiply by the derivative of the inner function, which would be 3, and that 3 will comfortably sit at the beginning there, and that's all it is. Do try and have a go at this one. Remember that when you differentiate cos, you get a negative introduced, so that's the derivative of the outer function multiplied by the derivative of the inner function, which is 5, and again I'm going to put the 5 at the beginning of the brackets. Great, so that should be nice and easy. I haven't done tan, but remember that's just sec squared. Let's look at a couple of examples of when it's the other way around and the trig's in the middle of the function now. Okay, so with these ones, the trig is the inner function. The outer function here is something cubed. So remember when we cube or raise any trigonometry to a power, it's the whole thing cubed. That's what we're doing here. It's just the 3's written in the middle, but it is that. So the inner function is now sine. So if you want to do the long way, then your substitution would be that inner function, and you would have u cubed. So you can have a go at setting it up that way. If you want to do the quicker version, then we'll do that now. Remember to write dy by dx to start, and we're differentiating the outer function, so it'd be 3 something squared. Just going to put the squared back where we normally write it, and we're going to multiply by the derivative of the inner function, so that would be cos here, and I'll just write that all in one long expression. Good. Let's try this one now, and I've used tan because I didn't do tan on the last couple of examples. So the 3 is a constant, so that's just going to stay there. We're going to differentiate the outside, so that means 2 times the something. And then multiply by the derivative of the middle, so that would be sec squared. Remember, when you differentiate tan you get sec squared. So just simplifying that again. Fantastic, and that's it. So do keep practicing those, do lots of different examples. Let's finish with an exam style question. I hope you can read my writing. So this question that I've made up just says, find the equation of the tangent to the curve y equals blah 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 at the point where x equals 2. So to get the equation of a tangent we need 2 pieces of information. We need a set of coordinates, which we've got half of already, and we need the gradient. So we get the gradient by differentiating. We can start by getting the y coordinate for this point here just by chucking it in the equation. So let's do that. So we know it passes through the point 2, 5. And now let's get the gradient. To get the gradient we need to differentiate, so I'm just going to write the square root as a power so we can differentiate it, and it's using chain rule, so we'll differentiate dy by dx. The outer function first, multiply by the derivative of the inner, so that will be 8x. I'm just going to tidy this up by putting that back down on the bottom there. Okay, we're wanting to find the gradient when x is 2, so we can find the gradient at that point by putting in 2. Of course you can use a calculator for all of this. And you can either leave that as a fraction, 8/5, or as a decimal, 1.6. And then putting that together to get the equation of the tangent, the straight line, I'm going to use y minus y1 equals x minus x1. You can look at my video on straight line stuff to brush up on this if you need to. But just putting all that in. Or you might use a different method. I've run out of space, so I'll just clear this blue stuff. Maybe we seem to run out of space. Maybe I need a bigger board. Nice way to give your answer is get everything on one side equal to 0. It's just convention really, but of course you don't have to. But that's it. That's the equation of the tangent. Well done if you got that right. Keep practicing. Hope that was helpful. Thank you for watching.